All right, friends. So today we're going to look at exponent rules. Okay. So the first rule we need to talk about is called the power of a product. Okay. First off, what does the word product mean?
The answer of a multiplication problem.
Okay, so this is telling me we have multiplication. Okay. So what we're doing is we're taking something that's multiplied and I'm raising it to a power. Okay. So I'm taking a bunch of things that are multiplied together and I'm going to raise them to a power. So let's go back to a basic one. What do you think happens if I take x squared and I take that and I raise that to the third power? What does that become? X to the fifth power.
X6 power.
X to the sixth power.
But your time is in the exponent, right?
So you multiply the exponents. 3 times 2 makes this x, to the sixth. Okay? So the same thing is happening here, except now I have multiple things happening. So I can wait for all the chatter to stop. Okay, so when I have something multiplied and they're both raised to the m, that means A is raised to that power and B is raised to that power. So that power kind of distributes to the powers inside of my parentheses and we multiply. So if we do this problem here, simplify 3a to the second, b to the fifth, all raised to the third. Well, what's the exponent on 3 right now? What's 3 squared? 9. Well, that's not 9, so that can't be 3 to the second. What's the exponent there if it's not written? 1. Anytime you do not have an exponent written, your exponent is a 1, because 3 to the first power is just 3. You did not change it. So when I do this, this is 3 times 1 raised to the 1 times 3, because I multiply my exponents. A to the 2 times 3, because I had a 2 and I bring the 3 over, and B to the 5 times 3. Okay, so all I'm doing is taking that exponent, that power on the outside, and I'm multiplying it by every exponent on the inside. So this becomes 3 to the third, A to the 6th, B to the 15th. Which then, Justo said, well, 3 to the third is 27. So my final answer is 27, A to the 6th, B to the 15th.
That's it?
That's it.
So you don't do anything with the other exponents because it's variables, right?
Because your variables are different. Because that's an A and that's a B, you can't do anything with them. They're different variables. If they were the same, we'd have to move on. Okay, so open this flap up. Let's do some more. Okay, what do I get when I have y times y to the 5th power?
Y to the 6th power.
Would it be y to the 10th?
Y to the 5th. Y 2 times 5.
So
y times 5.
To the 5th.
Y times 5.
Stop it.
Y times to the 5th power.
It stays the same?
No. Y to the second power times
I have yet to hear a correct answer.
It's
Y.
two.
Y raised to the
1
fifth.
times 5.
Y
Y times
raised to
and
the
Y
fifth.
times 5 and then what?
Not even close.
2 times 5.
Y
Then
and 5
10.
with 5 and Y 5s.
Would it be Y 10?
Y,
Y
Yeah.
25?
Y raised to the 1 is Y.
All right, let's break this down. So y is just y. What is y to the fifth? 5 y's. So this is y. Y to the fifth then is 5 y's. 2, 3, 4, 5.
Y raised to
Y to the 6, like I said.
So this is y to the 6th power. Listen, right. If you think you know the answer, I need you to stick with it, not sit there and play a guessing game because you're waiting to hear me say yes. No, that's not how it goes. Just because I don't answer you right away does not mean that you are wrong. I'm usually waiting for somebody else to catch on or you to be like, Miss Smith, I know I'm right. Can you just listen to me? Okay, m squared times m to the 7th.
Is it M to the 14th power?
No.
M to the 14th.
No.
14 M's?
How many m's do I have if I have m squared and m to the 7th?
M raised to the 10th.
M 7
14.
times.
M raised to the 10th.
It's M raised to the 9.
Is m to the what?
9.
9.
Ow! But I'm touching times here.
Okay, so your difference is if this was m squared raised to the 7th, then that is m to the 14th. When I multiply, this is actually 2 plus 7, which gives me 9. Okay, so you need to distinguish the difference between a power to a power and two things being multiplied together.
So when it's in the parentheses, there's an exponent. That's when the times.
Yes. Okay, so let's look at this one.
Are you serious?
Okay, so
R raised to the 2nd.
I have R times R. So that was what, Justo?
R squared.
R squared. I have 2 R's. How many N's do I have then?
3.
Mm-mm.
5.
No. 6. Remember, this is n to the 1st. So I have 1 n, 3 n's, 2 n's, so n to the 6th.
So,
Yes. Okay. Move over to here. Okay. Deal with your coefficients first. So I have -4 times -5.
20.
Positive 20. How many x's do I have if I have x to the 3rd and x to the 7th? 10.
That's the 10.
Okay. Yes. So -6, good, Maya. -3 times 2 is -6. J. Careful. There are 3. There are 2 here and 1 here. So J to the 3rd and K to the 10th.
I like J every day, multiple times. It's not fun.
Is this gonna get harder or do you stay like this?
You just have to recognize your rules. And these rules are kind of backwards, and I'm trying to figure out why they did it like that. Did I copy this wrong? I really did. I copied this wrong. That's why it looked goofy. Way to go, Miss Smith. Genius. I did. I messed up. I did. I did a great job. Go, Miss Smith. You stink. At least I can admit when I do something wrong. It happens.
Are you trying to say others can't?
I know
My
some
husband,
people.
big time. He don't like to.
My brother, he always thinks he's right.
Right. They always think they're right. I don't know. No, I copied this wrong, which is why the examples on the inside made no sense to what we just did on the outside.
Yeah, because it was different.
Rock on. All right, these ones will make sense though. All right, so a power of a power. So we talked about if I have something raised to a power, and then that entire thing is raised to a power, you multiply the 2 powers together.
So B15.
So b to the 5 raised to the 3rd, Sabi said is going to be b raised to the 15th, because you take 5 times 3. All right, so the ones on the inside of this one should make a lot more sense. So if you open this up, okay, we cannot go super fast because you are losing everybody else. You can't stay with me. I need you to be quiet and just do and then check your answers. I love you dearly and I love that you're rocking this, but you're going to have everybody else in this class that needs me go, I quit, I'm done, because we going too fast. So I need you to take a chill pill. Okay. All right. So y to the 5th squared is y to the 10th. Okay, be careful with this one because this is actually a mixture of what we're doing right now and what we did at the top. So exponents first. Let's take care of this. What's x squared to the 5th? X to the 10th. So then what's x to the 10th times x to the 3rd? 13. Okay, so we had that power of a power that we're doing right now, and then we went backwards to something like this and had to add them. So it's a mixture of the two. So you have to be careful. Okay, look at this one.
I think it's -3a and 1.
Okay, remember, that 3 has to go against every power in there. So there's a power here, there's a power here, and there's a power here. So this is -3 to the 3rd, a to the 3rd, b to the 12th. Remember, if there is no exponent written there, there is an unwritten 1. Okay, just like if I have x, it's 1x. Even though I don't write that 1 there, there's a coefficient of 1. There's always an exponent of 1. So now we need to actually finish this. What's -3 to the 3rd? -27. Because you have -3 times -3, which is +9, times -3, which is -27. a cubed b to the 12th.
That's it?
No. Let's do
One more.
negative 27 over 50.
That was all.
Okay, so we've got to take care of this first. So this becomes 4 squared a to the
So 4.
to the 4th. 2 times 2 is 4 times b to the 3rd. What else do I need to do to finish this off?
31. What was the question?
What's the last thing I need to do to this to get my final answer? Because I'm not done yet.
Get the answer for the 4.
4 squared. You know what 4 squared is. We have to get that.
16 squared.
16. A to the 4th, b to the 3rd. Okay. Let's take a look at this one. Simplify. What's going to happen if I have 4a cubed b times 3a squared b to the 5th?
4 square. 4 1.
12.
12.
Oh.
4 times 3,
Oh.
12. A cubed times a squared. A raised to the 5th. B times b to the 5th. 6.
Wait, what?
Don't forget, this is b to the 1st. So you have 1b and 5 b's. Okay, I'm going to tell you this right now. You want to start committing these rules to heart. Because when you get into math 2, we start radicals, which is square roots. You are going to need to know these rules to simplify square roots. Okay, I do. I don't know. It all depends on what they have me teaching next year. Because next year I'm also going to be teaching AP statistics. So I do not know. All right, let's try these ones. So these are the hardest ones yet. Oh man, here we go. All right, so first off, please excuse my dear Aunt Sally. Okay, so parentheses first. Is there anything inside the individual parentheses that I can do?
No.
No, I can't do anything with 4xy. I can't do anything with negative 2x squared. Okay, those are already simplified. So now I deal with my exponents. I need to multiply each exponent inside of this by 3. So this is negative 4 to the 3rd, x to the 3rd, y to the 3rd. I need to multiply every exponent inside of this parentheses by a 3. So this is negative 2 to the 3rd, x to the 6th.
So that 2 goes with that x.
This 2 right here?
Yes.
Yes. That's x squared. All right. So now what do you want to do? Coefficients. All right. So what is negative 4 to the 3rd? No.
Negative 58. Negative
48. Negative 58.
No, it's negative.
Negative 64.
Negative.
It's negative 64. Okay, you have to understand that 4 to the third is not 4 times 3. It's 4 times 4 times 4. So this is negative 64. X to the third, y to the third. What's negative 2 to the third? Negative 8. X to the sixth. Okay, so now I'm multiplying all these together. It's a long process. It is fantastic. I like it. I know you're being sarcastic, but I like it. This one is hard. Okay, now what?
Now we need to multiply 64 by
negative 64 times negative 8. What does that give me?
2,000.
Because that's a negative 8. Negative 2 to the third is negative 8.
It's 500.
512. Okay, what do I get when I take x to the third times x to the sixth?
X for 9.
X to the ninth. And there's nothing to do with the y, so it just drops down and stays y to the third. Whoa. It is. Please understand too, I try to do harder ones in class. That way when you get to finals, you get an easier version of what I've taught you.
Good.
And you're like, I don't want to dumb it down in class, and then you get the hard stuff on your test and you're like, I'd rather do the hard stuff now and think through it, and then you get your test and you're like, oh, I got this. So just because we're doing the worst of it in class does not mean that this is exactly what your final is going to look like. Okay, how would you approach this one?
I got it. No, I don't. No, I got
Distribute around that 4.
Okay, so we need to multiply all of the exponents in here by the 4, which means this negative 3 drops down. I don't even touch it. Negative 3 times 2 to the 4th times x to the 4th. I also have to do that same thing with this 2. I need to multiply it by every exponent on the inside. So 4 to the 2nd, x to the 10th, y to the 2nd. Okay. What do you think we should do next? Okay, so Sabi said I need to take care of this first. I need to take care of my numbers that are raised to a power. So I have negative 3. What's 2 to the 4th? 16. Remember, 2 times 2 is?
4.
Times 2 is?
8.
Times 2 is? 16. So 16, x to the 4th. What's 4 squared? 16. X to the 10th, y to the 2nd. Okay, so now what?
Combine the
Go ahead.
Combine like terms.
distribute your negative 3 to the 16.
coefficient.
Okay, so we basically have to multiply our coefficients. So we take negative 3, 16, and 16. Multiply them all together. You're fine, we're going down.
Negative.
14,736.
Negative. Huh?
What?
I got negative 768.
Okay.
768?
Yeah.
Okay, then I'm wrong.
Negative 768. Okay, who said combine your x's then?
I said combine
Okay.
like terms.
So, x to the 4th and x to the 10th becomes x to the 14th, y to the 2nd. You're going to see this again in math 2. I'm going to tell you that right now.
4 math honors.
In math 3, you're going to see dividing polynomials.
Polynomials.
What are math honors? What are math honors? You go just go with it.
Honors doesn't change the fact that I still have to teach you the same concepts in Math 2. Math 2 honors and Math 2 regular get the same concepts. I just teach at a faster pace in a Math 2 honors class, and we do a little bit extra. No, I do a lot more projects with the honors classes.
Oh,
Although we have a project in here.
How do you do a project?
I'm super excited.
right.
We're gonna do systems of equations, plan a city project that I found on Teachers Pay Teachers. Super excited. Yes. All right. What's my first step in this one? Okay. So I need to raise everything to the second power here. So this is 2 to the second, x to the second, y to the second. Okay. Didn't touch anything else because nothing else was raised to a power. Now what?
I think we parentheses like
Okay. Xavier says I need to get rid of that exponent. So we need to get rid of 2 squared. What's 2 squared? 4. This probably is the easiest one out of all of them. You're right. Okay. So what's this? What do I do now?
Oh, I thought you were
Combine.
Give it X's.
Multiply your x's.
Multiply. I would start with your coefficients. 4 times -3 times 4.
48.
-48. X squared times x squared,
4.
x to the 4th. Y squared times y to the 4th,
6.
y to the 6th. Either that one was easy or you guys are getting super good at this.
No, that one. I know how to.
Is I? She says it's I.
It's a boring.
It's a boring.
A game with this, bro?
So you know how the exponent became in what's inside? Those are you have exponents.
That's okay. You multiply the exponents. So when I bring this 2 through to multiply against my exponents, this becomes -3 squared j to the 4th, because 2 times 2 is 4, k to the 6th. Bring my 3 through. So this is 2 to the 3rd, j to the 6th, k to the 3rd. Okay. Let's get rid of our exponents. What's -3 squared?
+9.
+9. 9, j to the 4th, k to the 6th. What's 2 to the 3rd? 8. J to the 6th, k to the 3rd. So what's 9 times 8?
72.
Ooh, look at these multiplication tables in your heads. I love it. J to the 4th, j to the 6th. 10th. K to the 6th, k to the 3rd.
That's 9.
To the 9th.
Wait, go down.
Sorry.
We're done. I
I might stick with 2.
No, I might need a little help with this one.
You're gonna need some help with this one. I mean, I'm here, but I'm doing conferences today. So if you need a space to work, that is fine. But I cannot dedicate after school to absolute tutoring because I've got to get. Can you go to the bathroom? We're about to start notes on this last one. Quickly, I mean, like, go. We still gotta finish these last ones. We have a whole nother foldable.
What page is it going?
Okay. Let's glue these in while TJ runs to the potty.
Problem with that.
No one's going when I start these notes, so. 82! Guys, again, you have 10 minutes in between first and second period. There is no reason we need 50,000 bathroom breaks during second block. Especially you, Seth, because you come straight across the hall. There's no reason you can't use. Huh?
I did go.
And you gotta go again? Honey, you need to stop drinking so much water because you're not getting bathroom breaks when you right across the hall. Friend, it is good for you, but you also can't drown yourself.
And then you die.
You can. You can drink so much water that you can literally drown yourself.
Wait, for real?
Yes. There is such a thing as overhydration.
It won't have no space in your body.
That's something that would happen to me.
You can overhydrate.
Then you're gonna die. I think I'll be doing that.
Is that why whenever you drink too much and too fast, it starts hurting?
No, you're swallowing too fast.
It's not good to chug. It's not good to drink too much.
Oh, it's not good.
All right, gentlemen. I'm kind of curious as to why we're standing up.
I'm sure this is.
Come on. All right.
This homework is so.
All right. So we said on the last paper, if I multiply two bases that are the same, we add my exponents. So m to the second times n to the seventh becomes m to the 2 plus 7, which is m to the 9. Okay. So multiplying means I add my exponents. Well, quotient means we're doing what? What's a quotient?
Dividing.
Dividing. So if I add my exponents when I multiply, when I divide, we subtract. Okay, so if you look at this example right here, g to the third, h to the fifth, g to the first, h to the second in the bottom. So this becomes g to the 3 minus 1 and h to the 5 minus 2. So I subtract my exponents this time. It's always the top exponent minus the bottom. So we actually finish off as g to the second and h to the third. So please do not forget when the exponent is not there. Please do not forget when the exponent is not there, there is an unwritten 1. Okay, so that's where that 1 came from.
Why would you subtract?
Okay, so I can write this out. Let me show you what this looks like written out and why we came up with these rules. So I can technically take this. Let's see. My problem was g to the third, h to the fifth over g, h to the second. Okay. So I can technically write this out longhand. G to the third means I have 3 g's. H to the fifth means I have 5 h's. Okay. So this is the top written out long ways. Does that make sense? Okay. The bottom written out long ways is 1 g and 2 h's. So dividing, I can start canceling out. 1 g in the top cancels out the g in the bottom. 1 h in the top cancels out this h. This cancels out this. So I'm left with 2 G's, 3 H's. Look at your answer. 2 G's, 3 H's.
That's what
That's
Mr.
like the
Yamato
easy
taught
way
us.
to do it, right?
Okay? So you can do it that long way, but the goal is to start learning these rules so you don't have to spend your time doing it the long way.
Especially when it's like big numbers.
Okay? Yeah, especially when it's big numbers. Like if I have G to the 217th over G to the 32nd, no one wants to write G 217 times.
I do.
Okay? So that's where these rules come from. So everything that Ms. Diamato taught you, how to do it longhand, that's what we're doing, but now we're shorthanding it. Okay?
And she a great teacher.
Ms. Diamato, yeah, she's amazing.
Everybody would always say she could teach anybody.
She can. She is absolutely phenomenal.
I wanted to go to her, but I didn't have time. I had a busy life.
She's the MCL at the middle school now. She's not even in a classroom anymore. She's called the multi-classroom leader. She goes around and helps the other teachers with lesson plans and ways to implement stuff. And
Is that easy?
You should get paid more?
Like Miss Blackwell?
she's amazing.
Is she better than Miss Blackwell?
I had Miss Wilbury.
Miss Woodbury's good too. I got a lot of material off of Miss Woodbury.
Hey, Rashawn.
I've never actually met her in person. We've only corresponded through email. Okay, so this is technically 5 5s in the top and 2 5s in the bottom.
So would it be 5-3?
So 5 to the third. So this becomes 5 to the 5 minus 2, which is 5 to the third, which Justo said is 125. Yes, Brenda. Simplify what?
What? You say how it's 5-3?
To 125? 5 to the third is 5 times 5, which is 25, times 5 is which is 125.
Oh.
He just literally raised 5 to the third power. Okay, so m to the sixth over m to the fourth becomes
And for the second.
m to the second. This is m to the 6 minus 4. I'll have to tell Miss Diamato to watch my YouTube so she can hear her shout out. She likes to know that y'all still talk about her and love her.
Was it live?
I don't even-
Yeah?
Oh yeah, she is. What's it called? One day her husband brought his donut home.
Right,
And Pringles.
donuts.
And Pringles. Oh my, I didn't even have it as a teacher. It was
I know it's funny, guys, but welcome back to Math with Miss one-on-one.
All right, take a look at this one. I can only subtract exponents with like bases. So p to the fifth over p to the second becomes
P to the third.
p to the third. N to the fourth over n to the first becomes
And to the third.
n to the third. Rah! Yay!
8 for the second.
Okay, so number 4. A to the second over a to the first.
Hey.
Okay, so it's technically a to the first, which is the same thing as a. They're both the same thing. Just know that if it's an exponent of 1, they're not going to write it. The exponent of 1 just means I have a.
You did that to me, too.
She's slow.
Okay, what happens in number 5?
The X
The
goes
X?
bye-bye.
The x cancels out.
And his Y1.
So it becomes y to the first, or just y.
I do the X kind of harder.
X to the fifth over x to the fifth means all of my x's reduced down to 1.
What is
It's the same thing. So they reduce down to 1.
Oh.
Well, the reason why you come up with this 0.
Mm-hmm.
Subtract out.
And anything to the 0 power is 1. All right. Be careful with number 6. -1/7. -2/14 reduces down to -1/7. Y to the 7th over y to the 5th.
Y to the
Second.
Y to the 2nd. So you will more than likely see this written as -y to the 2nd over 7. They are more than likely not going to write that 1. A coefficient of 1 usually is never written, and an exponent of 1 is usually never written.
I think number 7 is catching up.
Okay, number 7, y over 2, or y to the 2nd. That's what you meant. I knew what you meant, and I said what you said. Okay, Xavier says my x's cancel out. They reduce down to 1. And anything times 1 is itself. It reduces to x to the 0, which is 1.
So, X.
There's no x.
You said X to the 1 is 1.
X to the 0 is 1. And 1 times y to the 2nd is y to the 2nd. There's no x's left.
What's this? What's this?
Yes.
Can I go?
Seth, I said you're not. You're not.
R to the 4.
Okay? So, r's. We've got 7 and 3. R to the 4th. N to the 4th. Your t's cancel out. Because again, I've got t times t in the top and t times t in the bottom. So these cancel. I don't have any t's left. My t's are bye-bye. Bye-bye.
Times. 1 to 4. You multiply this.
Okay. Next one. Oh. Power of a quotient. So now I'm still dividing, but now I'm going to take that division and I'm going to raise it to an exponent. So just like I had a product inside of the parentheses, and I took that exponent and multiplied all the exponents on the inside by that exponent on the outside, we're doing the same thing here. So what I mean by that, let's look at this example at the bottom where it says simplify. Okay, so my 2 multiplies by every exponent on the inside. So this becomes 3 to the 2nd, p to the 6th, over 7 to the 2nd. So 3 had an unwritten exponent of 1. 7 has an unwritten exponent of 1. So I multiply 2 times 1 is 2. 2 times 3 is 6. 2 times 1 is 2. So then I finish this off. This is 9 p to the 6th over 49.
Right.
Remember, 7 to the 2nd is not 7 times 2, so it's 7 times 7. That's probably what's going to catch some of you more than anything. You have got to remember, it's not the base times the exponent. When I raise something to an exponent, it's that base times that base,
Sorry,
times that base, however many times I need to. Okay, so we only have 4 of these. All right, so this is gonna be a mixture of what we're just learning with the one that we just did. So my first step then was to take this 3 and multiply it by every exponent inside of my parentheses. So this becomes 2 to the 3rd, a to the 6th, b to the 3rd, over a to the 3rd.
So that would be. So what's
Okay, so now, what is 2 to the 3rd power?
8?
8. What happens when I have a to the 6th on the top and a to the 3rd on the bottom?
3 bottom line goes.
A to the 3rd, because this is 6 minus 3, and b to the 3rd. That's your answer. As I add more things in, it becomes harder and harder.
We see.
You see, she says we see. Seth, seriously, go quickly.
Wait, this 3 still counts on the bottom?
Yes. So this 3 goes with every exponent. So this becomes 4 to the 3rd, p to the 12th, r to the 12th, over 3 to the 3rd, p to the 6th, r to the 6th. Okay, so the 3 multiplied against the 1 exponent on the 4. 3 times 4 is 12. 3 times 4 is 12. 3 times 1 is 3. 3 times 2 is 6. 3 times 2 is 6. So now, what is 4 to the 3rd?
64.
64. What is 3 to the 3rd?
27.
27. Okay. What happens when I have 12 p's on the top and only 6 on the bottom?
Bottom one is that.
P to the 6th
6 and Y to the 6.
and r to the 6th. There it is, my friends. Not that bad.
Great.
I did the 3rd one. This can't be.
Okay. This one. 2 to the 4th. R to the 20th.
Oh.
W to the 12th. Over R to the 16th. W to the 12th. So what's 2 to the 4th? 16. R to the 4th.
And the W is going to
And my W's will cancel out.
So that'll be 16 already.
Brenda, were you trying to reduce in the parentheses first? You can do that. Okay, so Brenda took a different approach to this. And you can do this. There is no rule saying that you can't. So, what Brenda did was she tried to reduce what's in the parentheses first. So, she kept the 2. She said r to the 5th over r to the 4th is r. W to the 3rd cancel out. And then she raised this to the 4th power. So then she has 2 to the 4th, r to the 4th, which is, guess what? 16, r to the 4th. She still got the same answer. That's okay. So the way that we're doing it, you're going to end up with bigger numbers. the way that she did it, you don't end up with such big numbers anymore. It's up to you. Either way, you're gonna end up with the same answer. So you were not wrong, girl. You rock it. Okay, this one. 3 to the 4th. R to the 24th. N to the 12th. Over 2 to the 4th. R to the 20th. N to the 4th. So what's 3 to the 4th power?
12.
It is not 12, Husto.
Right. You know that.
Huh? Wait, it's 81.
81. 81. What's 2 to the 4th?
Oh wait, no.
You were fine.
16.
16. R to the 4th. N to the
11. Wait,
8.
Oh.
Did you forget to do R to the, or N to the 4th in the bottom?
Yeah.
Okay.
All right, 0 exponents.
0 exponents. Okay. So, your rule for 0 exponents, I can take anything I want and raise it to the 0 power. When I do that, my answer is 0 every time. Okay, so A raised to the 0 power is 1. 7 raised to the 0 power is 1. So both of these answers down here are 1. Anything that I raise to the 0 becomes 1.
There's only one question on there that got 0. Yeah.
And then finally was 3.
Oh, why do they put negatives on this one?
Oh.
Why
I don't wanna deal with
why is
negatives
the
yet.
number system so weird?
I don't know. I don't want to deal with negatives yet.
Let's just not do it.
All right.
No.
We're going to hold off and do these tomorrow.
Oh,
Oh my god. I feel like my brain is full.
Your brain is full.